Hello students, welcome to AcadShala. As your exams are approaching nearby, so AcadShala has taken a step to start the 3R series, that is, you can recall, revise, retrieve your concepts in science in the best possible manner. So these 3R series will comprise of many parts which will include the whole science to revise the concept. So please avail the opportunity and start with us. So all the best. The part 1 is coming in your flow right now. Today we are going to do numericals, chapter 12, electricity. But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all. Here comes the first numerical. Find the electric charge flowing through a conductor in 1 minute if ammeter reads 3 milliamperes. Now students, always remember, whatever is given in the numerical, always write it down. That plays a very vital role in solving your numericals. Now, time is given 1 minute. So I've written 1 minute over here. And I, that is current, is also given, but it is given in 3 milliamperes. Okay. Now I have seen in the numerical that these two things are given, which has to be converted into something to solve the numerical. What I should do for that? That means, first point, I have to convert minutes into seconds and I have to convert milliampere into ampere. So this is the first criteria, always in numerical students, that you have to convert what is required in the numerical, whatever is the demand for the numerical. After converting into minutes into seconds, so the value comes out to be, that is 60 seconds. So the time is 60 seconds. Current, that is I, that was given in 3 milliampere, I've converted, that is 3 into 10 to the power minus 3 amperes. Now this is the required value which is suited most properly for the numericals to be solved. Okay, after doing this, my first step, now I see what I have to find out in the numerical. So they have told us to find out the electric charge flowing through a conductor. Okay, so Q is the charge and this I have put up as a question mark because this I have to solve with the help of the value, the data given in the numerical. Okay, now to solve this numerical, what I have seen and what I know is that is the I, that is current is equal to Q upon T. Now, if I know this formula, I can take out what I have to solve in the numerical, taking out what is there in my formula. So, if I know that is I is equal to Q upon T, so I will find out Q is equal to, that is I into T. So, I have made this my new formula with my original formula. And then after this, I will quote the values which I have taken out on my own. So current is, that is 3 into 10 to the power minus 3 I have written into 60. This I have taken out over here, 60 seconds. After writing this value, I will solve it in a very easy manner. How? I will multiply 3 into 60. I have written out 180 over here and then 10 to the power minus 3. More I will solve it. That is 180 upon 10 to the power 3. Why? Because when this negative sign, I have to remove it. I will take down this 10 to the power minus 3 down. And when I take it down, so this minus becomes plus and then 10 to the power 3. After this, I know 10 to the power 3 is nothing but 1000. So what I've done, 180 upon 1000, solve children, and then I get the value as 0.118 or 0.18 Coulomb. Finished. This is the way to solve the numerical. You cannot ratify anything in science. You have to make your concepts clear. You have to make your conversions clear. You have to make it what is the demand in the numerical and then start solving. But the first step is what is given in the numerical, what you have to solve it, then start with the numerical. Always remember, children. Okay, next numerical. The second numerical says a wire of length 10 centimeter has a resistance of 4 ohms. Okay. If the wire is stretched to double its length, find the new resistance. Okay. So many things we have to do it in this numerical. No problem. If we are clear with the concepts, we can do it definitely. Okay. Now seeing the numerical, I have come to know that it comes out, it shows in the numerical that I have two cases. Right, I have two cases. Okay, let us solve one by one, step by step, taking the help of our concepts which we are clear about. Okay, the first case, it is given length is 10 centimeter. Okay, R, that is resistance, is given 4 ohms. Okay, I've written here. Now in the first case, it is saying that these are the values in the numerical, right? Now they have also told us that in two cases, we have the same wire. That means if we suppose take a wire of silver, suppose if they are saying over here numerical that the wire is same, that is made up of the same material. Okay, but I take it as an example that the both wires are of silver. That is the material of the conductor, that is of the wire is silver. That is made up of the same material. If the wire is made up of the same material in both the cases, then the resistivity will be same. Always remember, this is the first concept you should know. Seeing what is the demand, what is the language of the numerical, I have come to know that resistivity will be same in both the cases. Why? Because both materials are same. That is, in both the cases, the material is same, that is silver. Clear, children? Now, in the first case, if I've come to know that the resistivity is same in both the cases, so what I will do? I will take out the resistivity in the first case, and then after taking out the value of the resistivity from the first case, I will put it the value of resistivity in the second case. Am I clear, children? Okay, now what I will do it, I will solve it in the first case. So this criteria you have to keep it in mind, this concept. That again I'm repeating, children, it's very important for numerical to solve that in both the cases the material is same. For example, we have taken it as an example of silver. If the material is same, the resistivity will also be the same, because resistivity depends upon the material, that is the conductor is made up of which material. Material is same, so resistivity is same in both the cases. Now let us solve. Length is 10 centimeter given. Resistance is 4 ohm. Fine. I know the formula to take out the resistance. I will write it. R is equal to, that is, this is, children, rho L upon A. What is rho? This rho is nothing but the resistivity or the specific resistance. Okay. I know the value of resistance. I will put the value of resistance 4 ohm over here. I put up rho. And 10 is what? The 10 is nothing but the length. So I put up the value of 10 upon A. Right? After this, again I will solve it further. That is 4 into A. 4A is equal to rho 10. Okay. Now I have to find out the value of rho. That is the resistivity. So I will write down resistivity, that is rho is equal to 4A upon 10. Okay. Now 4A is equal to rho 10. That is more simplification. Then rho is equal to 4A upon 10. I will cancel it, and then the final answer, I got it as rho is equal to, that is resistivity is equal to 2A upon 5. Now I know the value of resistivity from the first case. Now what I will do, I will put up this value of resistivity. I will pick up from the first case and then I will put up in the second case. Why I will do this? Because in both the cases, the material is same, that is silver. And if the material is same, resistivity is also same. I am repeating this on and on in the numerical because it is very important, children, for numerical. Children do it wrong and then the answer finally comes out to be wrong. Okay, let us move to the second case. In this case, according to the numerical, we have seen that in second case, what we have done, if the wire is stretched to double its length, find the new resistance. Okay, in second case, it is double. That means in the first case, it was 10 centimeter. Now it is 20 centimeter according to the demand of the numerical. Okay, resistance, I have to find out. That is the new resistance. In the second case, I have to find out. Fine. I know the formula again. That is resistance is equal to rho, that is resistivity, L upon A. Now I will put the value of what? That is the resistivity from first case in this. But before that, we should always remember that in this case, the area will be different. But why the area will be different? Now, suppose children, you take an example of day-to-day examples, day-to-day life. Like suppose if you take a rubber band and I tell you to stretch it out. That means you pull the rubber band. Okay, you say, ma'am, okay, fine, I will do it. So you have stretched, you have pulled up the rubber band. Now, when you stretch the rubber band, what will happen, children? Right, correct. So that means the length will increase. Of course, the first criteria you told me. Fine, very good. Ma'am, the length will increase. I said absolutely correct. Then I asked you, beta, what else? So you will think it over and then you will put up the answer. Ma'am, length will increase and also it will become narrow. Yes. So the first thing, after stretching the rubber band, the length will increase. And second, it will become narrow also. That is, cross-section area becomes less. After this, I know this, that is R is equal to rho L upon A. And then I have put up R is equal to rho, that is length, that is it is 20. I have written the value 20 upon A upon 2. Because I told you just now taking an example. So in this case, in the second case, area will be, that is A upon 2. So this A upon 2, I will put it in place of this area, the value A upon 2. Now after this, we are putting the value of rho, which I took out in the first case. So I will put up the value of rho in the second case. After putting the value, see over here, I put up the value. So after this, what I have done, I have put up the value. So 2A upon 5, that is after simplification, I got the answer as 16 ohms. Simplify the calculation and then I got the answer as 16 ohm. So what we have to keep it in mind, children, again I'm repeating. First of all, always in the numerical of resistivity, always think it over. The first point you have to think it over, you have to find out is whether the conductor or the wire, whatever is given in the numerical, is the numerical saying it is same or not. If it is saying same, so that means what? That is the resistivity will be same because the wire or the conductor is made up of the same material. So immediately you will say yes, resistivity will be same. Second, that means if you know the resistivity is same and there are two cases, so whatever value comes out in the first case of resistivity, you will put that value in the second case and then you will take out the numerical. The second case will be solved, but always keep it in mind whether it is saying stretched or not. So the area will also be different. Always keep it in mind because this is a very, easy and common example of life. So always remember when you stretch a rubber band, So what will happen? You keep an example of rubber band in your mind. So of course, it will be there in the conductor, in the wire. Even if you pull up the wire, length will increase and the cross-section area will also become less because it will become narrow. Keeping these concepts in mind, children, you will come to know that placing the concepts, you will be able to solve the numerical very, very easily. Always remember, children. So these concepts to be kept in mind and then solve it. So these concepts to be kept in mind and then solve the numerical. So that's all for today, children. So keep on revising the numericals with AcadShala and keep on subscribing the channel. And of course, the chain should not stop of sharing. That is, sharing is caring, caring is sharing. So with this, I wind up the session. Thank you. Bye-bye. God bless.